Hello, friends. Today we are going to take a look at a multifunctional tester for diagnosing network cables, the FNIRSI LPM-10A. Let's start right away with what the device can do. It allows you to easily find the cable you need among dozens of others. It checks all 8 conductors and the shield, displaying the result for each contact separately. Here, the device detected a break in the 4th conductor and no connection through the shield. A separate QC mode analyzes the crimping quality of an RJ45 connector without requiring the other end of the cable to be connected. The screen displays the T568B wiring scheme and the contact where the device detected a problem. When connected to active network equipment, the LPM-10A determines the negotiated connection speed and duplex mode. In this case, the port established a 1 gigabit per second connection in full duplex mode. In PO mode, the device shows the voltage on each conductor, the pairs being used, the protocol, and the power class. Here, it detected the IEEE 802.3AF standard, a voltage of 46.7 volts, and power class 3. It measures the cable length separately for each pair. This can help not only estimate the total length of the line, but also reveal differences between pairs if the cable is damaged. We'll take a closer look at all of this later in the review. Structurally, the FNIRSI LPM-10A consists of 2 devices. The main unit performs measurements, generates the test signal, and displays the results, while a separate receiver is used at the opposite end of the line for cable tracing and connection testing. A typical workflow looks like this. The main unit is connected to a cable, network socket, or patch panel port. Depending on the selected mode, it can test the line, inject a tracing signal into it, or determine the parameters of connected network equipment. At the other end of the line, the receiver can be used to find the required cable among several similar ones, and it can also serve as a remote module when checking the pinout. In other words, the 2 devices complement each other and allow the line to be diagnosed from both ends. Let's take a look at what comes in the package. The tester arrived in a cardboard box sealed in plastic. The front lists the main functions: cable tracing, conductor continuity and sequence testing, PO operation, audible cable detection, and illumination. The tester and receiver are shown as they appear in the actual working kit. Inside is a fabric zippered carrying case. It helps keep the main unit, receiver, and supplied cables together, while also protecting them from scratches and minor damage during transport. The main unit and receiver are secured with elastic straps, while the accessories are stored in a separate mesh pocket. A printed user manual in English is also included. The kit consists of an LPM-10 transmitter with a color display and a separate receiver. The transmitter generates the test signal and performs measurements, while the receiver is used for cable tracing, conductor sequence testing, and AC voltage detection. The package includes a USB Type-C cable, a lead with clips, a wired earphone, a short flat patch cable, and an RJ45 to RJ11 adapter. The clips allow the tracing signal to be applied to individual conductors, while the earphone makes it possible to work in noisy environments. The manual includes a comparison table for the LPM-10A, LPM-10B, and LPM-10C versions. All of them support cable tracing, wire map, port flash, speed detection, length measurement, and PO testing. Version B adds fiber optic functions, while version C adds a ping test and IP address scanning. The main unit is housed in a compact enclosure with a large color screen and a set of physical buttons. Separate power and confirmation buttons are used for control, along with a 4-arrow navigation pad, which makes it convenient to switch quickly between modes without using a touchscreen. There are 2 RJ45 working ports on the right side. The first is used for length, flash, and PO modes, while the second is labeled QC/cont and is intended for checking crimp quality and line continuity. This separation makes operation simpler and reduces the risk of connecting the cable to the wrong port. From the top, the overall layout of the enclosure is clearly visible. The display occupies most of the front panel. The controls are positioned separately, and textured inserts on the sides provide a more secure grip. The enclosure has a utilitarian appearance, with no decorative elements and a clear focus on practical use. There is a separate scan port on the end of the unit. Through this port, The main unit injects a tracing signal into the line when the device is used for cable tracing. The connector is positioned separately from the other test ports, so it is difficult to confuse it with them during operation. At the bottom, under a rubber cover, there is a USB Type-C port. It is used to charge the device and update the firmware. The cover protects the connector from dust and accidental contamination, which is especially useful for a tool that may be used away from a clean workbench. The receiver has an elongated housing with a tracing probe at the end. The rotary control both powers the device on and adjusts its sensitivity. Separate buttons activate scan and NCV modes, and 3 indicators show the power status and selected function. On the side, there is a 3.5 mm connector for the supplied earphone and a USB Type-C port under a rubber cover. The receiver's built-in battery is charged through the Type-C port. There is an RJ45 port on the bottom end. It is used together with the tester's main unit for checking the pinout and conductor sequence. Next to the tracing probe is a built-in LED flashlight. It is switched on with a separate button and illuminates connectors, cable cabinets, and cable routes when working in poorly lit areas. After powering on the device and selecting the language, Chinese and English are available. The main menu opens. The first page contains cable test for checking the pinout and conductor continuity, scan for cable tracing, flash for locating the connected port by its blinking indicator, and length for measuring the line length. The second page contains QC test for checking RJ45 crimp quality, speed for determining the negotiated connection speed and duplex mode, and PoE for analyzing power over Ethernet. The final item opens the system settings. In the settings, you can select the interface language, adjust the screen brightness and volume, and configure automatic shutdown. The About section displays the firmware version and provides an option to reset the settings. The interface is simple, with all major functions available directly from the main menu. We'll begin testing with cable scanning and identification. First, let's check the standard normal mode. I connect the main unit to the black cable with the blue connector through the scan port, select normal, and enable tracing mode on the receiver. Now I bring the receiver probe close to several patch cables lying next to each other one by one. It barely reacts to the neighboring lines, but as it approaches the connected cable, a clear audible signal appears. The sensitivity can be adjusted further using the rotary control. The second option is noiseless mode, which is designed for tracing with improved resistance to interference. Now I connect the tester to one of the blue patch cables and switch the mode on the receiver as well using the skin button. The transmitter and receiver must operate in the same mode. I repeat the same test with several neighboring cables. Once again, the receiver confidently identifies the connected line and barely reacts to the others. Under these conditions, both modes performed well, and I did not notice any significant difference in cable identification accuracy. Cable test mode provides 2 testing options. Far end is used with the receiver connected at the opposite end of the line and shows the actual correspondence between contacts. Switch is intended for a cable connected to an active Ethernet port. Let's start with far end. With a standard unshielded patch cable, all 8 conductors are connected directly, 1 to 1, 2 to 2, and so on through 8 to 8. The G line is shown as absent because this cable does not use shielding. For comparison, I connect a shielded patch cable. Here, in addition to the 8 conductors, the tester also detects the G connection. The cable shield is connected from one connector to the other as well. Now I am using a cable where the conductors on contacts 1 and 2 in the first, orange pair have been swapped. On one end they are white-orange and orange, while on the other end they are reversed. At the same time, the cable remains fully functional. For Ethernet, reversing polarity within a pair is not critical and the connection will work normally. If this cable is tested in far end mode, the tester identifies the first pair according to its own display logic. The screen shows that the first and second conductors correspond to the first contact, while the other conductors and the shield are displayed normally. In other words, The device registers the peculiarity of the first pair, although the cable itself remains fully operational. Now I connect the same cable to an active switch port and test it in switch mode. In this case, the tester shows a normal working line with no pinout errors. In other words, when connected through active network equipment, this cable is identified as operational, confirming that it works normally in practice. The next test is an actual conductor break. The fourth conductor is broken, and cable test marks it with a red cross. On this same unshielded cable, the absence of the G line is also displayed separately. There is a separate QC test for checking the crimp itself. The other end of the cable does not need to be connected. The device analyzes the contact directly inside the connector. On the same faulty cable, it also detects a problem on the fourth contact. On a properly crimped connector, all 8 positions pass the test. So, cable test is convenient for checking the entire line and the pinout between both ends, while QC test allows you to quickly check the quality of RJ45 installation from one side of the cable. Now let's see how the FNIRSI LPM-10A measures line length. I'll start with the shortest patch cable, about half a meter long. In this case, the device was unable to determine the length at all and displayed the message out of range. The next test uses a 1 meter patch cable. Here, the tester does provide a result, but it is not quite what I expected. For pairs 1 to 2 and 4 to 5, it showed 2 meters, while for pairs 3 to 6 and 7 to 8 it showed 0. So, with a very short cable, the measurement was incomplete and unstable. Now I connect 2 identical 1 meter patch cables in series, giving a total line length of about 2 meters. This time, the length was detected on all pairs, but the result was too high. The tester showed 3 meters instead of the actual 2. I add another 1 meter patch cable, bringing the total length to about 3 meters. Here, the device measured 3 pairs correctly at 3 meters, but pair 1 to 2 once again showed an error, with a result of 4 meters. Now let's move on to a longer line. A cable slightly more than 7 meters long was measured by the tester as 8 meters. Here, the result is already closer to the actual value, although a slight overestimation still remains. And the final test uses the same 7 meter cable plus 3 1 meter patch cables, giving a total line length of slightly more than 10 meters. In this case, the device showed 12 meters. So, on longer lines, this function already provides a useful approximate estimate, but it cannot be called a precise measurement. The results are noticeably rounded and may be higher than the actual length. Now let's test how the LPM-10A works with active network ports. I'll start with PO on a popular UPS that can provide several output voltages. In the first mode, the tester detects 15.3 V on contacts 4 and 5. The power supply is non-standard, so the protocol and power class are not detected here. I switch the output of the same UPS to 24 V. The tester responds correctly to the change and shows 24.1 V on the same contacts 4 and 5. As in the previous case, this is passive PO, so the IEEE standard and power class are not displayed. The next UPS already works with standard PO. At its output, the tester shows 46.7 V, detects the IEEE 802.3 AF standard, and identifies power class 3. So here, it displays not only the voltage and contacts being used, but also the parameters of the negotiated PO connection. I check the PO port of a separate switch. Here, the device detects 51.8 V on contacts 1 and 2, identifies IEEE 802.3 AF, and shows power class 3. At the same time, you can see which wiring scheme is being used to supply power. On the same PO switch, I switch to speed mode. The tester negotiates a connection and shows a speed of 100 megabits per second with full duplex. So, it allows you to quickly check not only whether PO is present, but also the actual operating mode of the Ethernet port. For comparison, I connect the LPM-10A to one of the regular gigabit switches. Here, it detects a 1000 megabits per second connection, also in full duplex mode. This means the speed function allows you to quickly distinguish a 100 megabit port or line from a gigabit connection. I start the flash function to locate the required port on the switch. In this case, the tester is connected to the third port, and its indicator begins to blink, making it immediately clear where the cable is connected. The flash function is convenient for quickly identifying a line without manually tracing it. It is especially useful when working with switches that have a large number of ports, where you need to quickly find the required connection among several identical cables. I have now switched it to the first port. The FNIRSI LPM-10 turned out to be a genuinely multifunctional tester. It can do more than just check cable pinouts. It can also measure length, detect PO, determine link speed, locate a port using flash, and work as a cable tracer. The device performs best in basic everyday tasks: checking cables, finding breaks or swapped conductors, testing PO, determining connection speed, and identifying the required port on a switch. For this kind of work, the device is genuinely convenient. However, there are some limitations. The length measurement works more as a rough reference. With short cables and assemblies made up of several patch cables, the results may differ noticeably from the actual length. So, for precise cable analysis, this is not a professional reflectometer, but rather a general-purpose consumer tester. Overall, the device left a good impression specifically as a versatile networking tool. For a home workshop, installation work, local network maintenance, and quick diagnostics, its capabilities are more than sufficient, especially if you need a single device for several different tasks at once. That's all for now. I hope the video was useful and interesting for you. I would appreciate your likes. They help promote the video on YouTube. If you don't want to miss new reviews and smart home tutorials, subscribe to the channel. You'll find all the links mentioned in the video, as well as my Telegram channels, social networks, and discussion groups in the description below the video. Thank you for watching. See you next time. Peace to everyone.